Minute of the hour, and it's time to start. Welcome to the MySQL High Availability Landscape and where Galera Cluster fits in Codership webinar that you're here for today. You're here for the European and Asian edition in terms of timing. There will be another one running later today for the Americas. I'm Colin Charles, and I'm here to talk to you about HA in general. This is our agenda for today. We're going to go through a little bit of an introduction of what Codership is all about, what is high availability, how people are handling redundancy through MySQL replication, the failover frameworks that are available today. Typically, proxies need to be covered. Galera Cluster, so we can go a little bit deeper into it. Cloud-based solutions that exist, and general conclusion. So Codership is a company where we generally like to say we are the developers and experts of Galera Cluster because you can't go wrong with getting stuff from upstream. The company itself has been established in 2007. Three founders, all of whom are engineers, Seppo, Timu, and Alex, all pictured on this slide because they actually managed to get MySQL Community Award for being a great product in 2014. The business model is entirely services based, so software that is produced is 100% open source. And I think the most important thing about Galera Cluster that you really want to always remember is that Galera itself is widely used software, it's widely tested software in all kinds of different applications and industries, typically used for people that cannot tolerate any downtime, data loss, any lost transactions, and then, of course, people who also like the ease of use in terms of cluster setup. And when it comes to industries, there are just so many industries that use Galera cluster in production without any issue. We've got users in e-commerce, betting, gaming, telecoms, banking, insurance, actual games in real time, healthcare, media, marketing, advertising, travel, education, software as a service platforms, platform as a service, as well as infrastructure as a service. And people are happily running a minimum of 3 nodes without any issue, generally speaking. So, what is high availability? And I'd like to draw you to a few thoughts around high availability. For one, we always think of high availability as also being highly performant and also highly scalable. So this is typically things where we talk about throughput in transactions per second, typical in the MySQL world to measure transactions per second. If you come from a more commercial database background, you may be thinking about transactions per minute. It's also about latency, where we talk about response times, which you can measure in percentiles. And latency is also very important when you're running clustering, because clustering that works over a wide area network or in what many people use today, the cloud, definitely you want to make sure you have low latency as possible. But high availability is also about durability. The D in ACID ensures that you definitely must not lose commit data, which is why people typically have replicas of their data. They do either sometimes they do snapshots and then they do point in time recovery, and there's also backups. Replication naturally is also about redundancy. So you want to have multiple copies of your data at any given time. That tends to be quite handy as well. And when it comes to clustering, you also definitely need to think about, quick failover. Automatic failover is definitely preferred. Quick recovery without restoring from a backup, as well as monitoring. And the ideal goal of high availability is that you don't find one single point of failure. So we're trying to get rid of the idea of having a single point of failure and always being available, no matter what the requirements of your application are. And we know that in today's real world, being down for a minute is a very expensive proposition, especially if you're an e-commerce site. And typically, we see lots and lots of people doing lots and lots of transactions at any given time. So you want to avoid downtime at all costs. There are myriad solutions out there when it comes to using gaining high availability. Galera Cluster and the distributions of Galera Cluster like MariaDB Galera Cluster and PerconXDB Cluster are just one example of the myriad solutions that are available. Linbit's DRBD has been around also probably for as a little bit longer than Galera Cluster and is typically used in Linux scenarios. And some people you definitely use DRBD. There's also failover frameworks like MySQL High Availability MHA, MySQL Failover Orchestrator, which there's also NDB Cluster, which was arguably maybe the first NoSQL storage engine out there, which MySQL acquired back in the day and tried to get it integrated into MySQL itself with the SQL layer. And NDB cluster is used in telcos typically. Group replication and MySQL InnoDB cluster, which I consider the new kids on the block, because this is something that Oracle has been pushing heavily, and we will have a dedicated slide to this later as well. And of course, the cloud, with lots of HA out of the box. Basically, if you go to Amazon or Google Cloud or Microsoft Azure, you can get HA out of the box just by clicking a GUI button without having to manage your database. And of course, we're going to have to talk a little bit about proxies, like router, which actually you would use for configuring InnoDB cluster, MaxScale, which you would use when it comes to MariaDB, and Proxy SQL, which works alongside all servers. So now is a great time for me to also basically launch a poll. So this is interactive. You should see a little pop-up now, basically saying what database are you using. And it's a quick poll. Please feel free to give me some feedback to see what you're using. And when I've gotten a significant amount of answers, I will close the poll. So a few of you have still not voted quite yet, but I'm looking at the stats, and people are definitely on MySQL 5.7 and earlier by quite a chunk, followed by MariaDB, which is also very popular. So few more laggards want to vote. Whoa, MariaDB. MariaDB's just taken over MySQL 5.7 or earlier. How about that? And now they're tied. We should run some kind of vague bet, though I suspect that's not something we could do. Okay, so we're still collecting responses, and we've got a pretty good response rate. So I think I will close the poll because I've got another question for you. So yeah, it turns out MariaDB has won this quick poll, and another question that I have for you is, what HA solution are you, using or planning to use? And naturally, I suspect you've all come from a Galera cluster list, but you may also be using, regular asynchronous replication, which is, primary, secondary, master slave replication. You may also be using semi-synchronous replication, which is a plugin that is quite famous in MySQL and MariaDB worlds. You may be using RDS, Aurora. You may also be using, group replication or InnoDB cluster, or thinking about using any of these solutions. So we've got about 2/3 of the people voting. Could we just get a little bit more, and then we'll take a look-see, and I'll close the poll. 10 seconds left to tell us what you're using or planning to use. Well, it turns out Galera Cluster seems to be something you are either using or planning to use, which is great. So I will also close that poll, followed by asynchronous replication. Okay, so let's talk a little bit about uptime. A lot of people say, hey, we want 5 nines uptime, or even more, frankly. And when you say you want five nines uptime, it means your max downtime that year is that you're measuring should only be 5.25 minutes of service unavailability, and this is your level of availability. And a lot of people say they like 5 nines uptimes, and the average site, according to many sites, basically suggest that people get a fraction past even 3 nines. So you do get a fair amount of downtime every year in a production scenario. And I guess it's probably would be remiss for me not to mention, but I'm sure many of you use services. In the last couple of months, you've seen outages of, say, Google's services due to failure of a storage component. Facebook had some failures as well that took several hours, and they didn't quite release the incident report. Downtime happens, and generally we all want to be you know up there 5 nines uptime, but it may not necessarily be the reality. So there's fashionable and then there's reality. So it also depends on what your application is doing, and also and also what kind of architecture you have, and also what kind of levels of availability you can afford. Because Galera, for example, can support 3 data centers, but many people say they may not be able to afford the third data center, and they only want to afford maybe two data centers, and then you may not be fully available. So generally speaking, I'd say regular asynchronous replication doesn't have automatic failover, so you have to do manual failover, and that's when you end up having to use some kind of failover framework, maybe like MHA or DRBD or Orchestrator even lately, and that with semi-synchronous replication can easily give you 3 nines, maybe even a little bit more than 3 nines uptime. A SAN generally never promises a very high uptime because it can also be a great downfall. Um, but then things like NDB cluster and Galera cluster, and I guess to a certain extent, the group replication with its configuration should aim to give you close to 5 nines worth of uptime. So when you deal with downtime at scale, you really are measuring in thousands of hours. Because failures generally don't trigger ops to come back, because you obviously have replicated copy of the data being served elsewhere. And HA is all about redundancy, right? So you definitely use RAID. So if a disk goes away, the rest of your RAID array continues working. If you use a cluster for say even file storage and so forth, if one crashes, definitely a bunch of others continue working. Um, most rack mountable servers you buy today basically come with at least 2 power supply units. So you have redundant power supplies. You tend to have several network interface cards, so you can always have another route. You don't necessarily want to keep everything on one switch. And also you have to think about geographical redundancy, because data centers can go offline, and they can get destroyed, and you need to send computation to another data center. So one anecdote that I generally like to go back to is how one day I landed in South Korea, and I needed to swipe my Amex as soon as I landed, because I was getting to a hotel, and the Amex wouldn't work. And it turned out it's not because the Amex wouldn't work. It's because Amex was down in all of South Korea for 1 week, and that was because the data center that handled Amex transactions, amongst other things, actually went up in flames, and while they had a high availability solution with another data center, they didn't quite test a disaster recovery plan, and it was about a week's worth of downtime for American Express inside of South Korea. Of course, it wasn't only American Express that went down. If you had a smart TV, those smart TVs became fairly dumb, and so forth. So high availability is totally about redundancy, but I think one of the important things about a HA plan in general and a DR plan is that you also test recoveries. So Netflix is famous for saying they have something called Chaos Monkey, which introduces chaos in the cloud. I think that's a generally very useful feature. Yeah. Okay, so high availability is also about the durability of your data. So data is obviously stored on disk, but you want to make sure it's actually written to the disk because you may think you've made a commit, but it's not written to the disk, and if the power goes away, um, so does your data. Um, all modern MySQLs and MariaDBs obviously have something called group commit in the binary log. So while it may not necessarily call fsync on each and every commit, it will group those commits and call them, say, one every three, for example. And that tends to be ensuring your data is durable. And this is all part of why we want to assure ACID compliance, right? The atomicity, consistency, isolation, and durability. Because in the event of a crash, you want to be able to say, hey, I can actually recover, say, the data. HA for databases may be a little bit more complex because you're not only thinking about hardware resources, but also the data that needs to be redundant. It's constantly changing data. So, even with Galera, you're always having, inserts, updates, and deletes and so forth. And you want to ensure that your operations continue uninterrupted without having to restore from a backup. I think that's clearly very important. There are many HA solutions out there that are not going to be covered in today's webinar. That includes some Java people love, which is client-side XA transactions, basically writing the same data twice. SAN, because SAN is really a scale up versus scale out, and it's fairly expensive. It's not the MySQL way, basically. Virtual machine-based failover. I mean, lots of people roll out instances in virtual machines nowadays, and VM-based failover is definitely not covered. NDB cluster I consider to be fairly niche. I'm going to throw in a bunch of commercial solutions that are interesting. Several lines cluster control has a community and an enterprise edition. While it's not a high availability solution, has a really nice GUI that works well with rolling out Galera Cluster. So kudos if you would like to try that. And then there's Continuous Tungsten Replicator, which used to be open source, but isn't any longer. So now the downloads are available for customers. And that also did actually have high availability solution around it, where it would basically consume the binary logs of MySQL and then put them in a THL, a transactional history log, and then ship them across the network. Then you can do other things with it. But now that it's no longer open source, it seems a little bit less interesting, so to speak. So one thing that we should probably definitely cover is DRBD, because this is redundancy through disk replication. Some people totally like the idea of RAID over Ethernet. If you're used to a SAN, DRBD can be extremely good for you. If you don't want to lose a transaction, but you can choose longer failover time, DRBD can be good for you. It's synchronous because it replicates the block from your primary server to a secondary server. However, keep in mind that the secondary server is passive, acting as a hot standby, and CFOs typically hate this because you have two servers, but only one is serving traffic and one is acting as a hot standby. Then there are ways to mitigate this, where you run two DRBD instances on each machine, and then you do cross disk replication. But again, this is not something you would like to delve into. DRBD was definitely hot technology more than 10 years ago. Failover time can be a little longer, depending on the size of the data and the needs to warm up the standby server. It definitely has worse single node performance with high average latencies, and you can actually see this later on. We talk a little bit about the RDS. Okay, so redundancy through MySQL replication is probably interesting. Now, when we ran the poll, I mean, most are either looking at because the question did say what are you using or planning to use, and 90% said Galera cluster and only 10% said asynchronous replication. So I'm not certain if you guys are you're already using async, for example, a default replication, or you're just planning to use Galera. But anyway, let me give you a quick intro to this. Replication in MySQL by default is asynchronous, and for a long time was always just statement-based. But row-based came around in MySQL 5.1, and in MySQL 5.7 it became the default. Uh, uh, it switched to row. Naturally, MariaDB decided around 10.2, instead of using row-based replication, they decided to use mixed mode replication, which by default is statement-based, but will switch to row-based if it calls a dangerous statement like a UUID function or a user-defined function, a load file, two or more increment columns that are updating the same statement, and so forth. So of course, these are just defaults. You can change them in your my.cnf. It's entirely possible for you. And then, of course, it's worth noting that semi-synchronous was introduced as a plugin in MySQL 5.5. It became better in 5.7 and MariaDB 10.3. And MariaDB 10.3, instead of having it as a plugin, decided to build it right into the server, which means that the configuration is a little different from MySQL, but you're getting the same semi-sync idea. And semi-sync, the idea is basically the master, basically writes events to a binary log, but doesn't know whether or when a slave has retrieved and processed them. That's asynchronous. So, asynchronous, you get master crashing, transactions committed might not be transmitted to any slave, secondary, so to speak. And however, with semi-sync, thread performs the transaction commit on the master. It'll block after the commit is done, and will wait until at least one semi-synchronous secondary acknowledges that it has received all events for the transaction or until a timeout occurs. And this is definitely something lots of people tend to also use, semi-synchronous replication. Then we of course have lots of failover frameworks. So the one thing that MySQL and doesn't do well out of the box is it doesn't just have a failover out of the box. Like you can't install MySQL, say, hey, I'd like to have 3 nodes in a GUI via a GUI, and then say I'd like to have failover out of the box. That just seems to not work as well as we expect. And when you use asynchronous or semi-synchronous replication, you definitely will use a failover framework. And typically, if you're going to use a failover framework to do automated failovers, is when a primary dies and a secondary takes over as the new primary. You definitely want to use semi-synchronous replication so that at least one secondary has managed to have access to the data. And Orchestrator, which is a tool that's been around for a fairly long time, it was developed at Outbrain and then Booking and then GitHub. It has a GUI now to handle failover. MHA has been tried and tested for a long time. It's written in Perl. It does require you to set it up. It can take anywhere between 10 to 20 hours to set up and test a live scenario. And that's something that you can also use, but you definitely need to know some scripting. MySQL Utilities comes with MySQL Failover as well, and it's still I'd say fairly new. Of course it's been around for some time, but I don't see many folk using it. If you have Linux skills, Pacemaker has resource agents, and they tend to exist, and they're all relatively good as well. But then you also depend on Linux as well. One caveat, of course, is not all the tools work with MariaDB server. Example of that is because the global transaction IDs that MariaDB server uses is different. But there is a tool called Replication Manager that works with both MySQL and MariaDB GTIDs. So for a good example is MHA can do automatic failovers by diffing the logs and copying data over. However, if you have MySQL Global Transaction ID, MHA can just use the GTID position and it doesn't have to do diff any logs, whereas with MariaDB, you'll still have to diff logs. So you could potentially achieve a faster failover with MySQL and MHA. Of course, this can also be patched. I mean, someone can submit a patch to MHA to make it understand the GTID of MariaDB server as well, because that's the beauty of open source. Now, I guess this is the one other thing that's kind of important to remember is that this is not built in when you're dealing with asynchronous or semi-synchronous replication. This is something you have to go out of your way to get going. And I think that's where something like Galera Cluster tends to differ, because it's not an afterthought, it's actually built right in. Proxies are definitely well worth covering. There are many proxies out there. Some people even use Nginx as a proxy. But I'm going to focus on just a handful. MySQL router is an important proxy to think about, because it's part of the InnoDB cluster offering. And of course, all proxies do transparent routing between application and the backends. MySQL router, of course, only works with MySQL. It doesn't work with MariaDB. And you can control it fairly easily via the MySQL shell, and configure your InnoDB cluster and router from that as well. MariaDB MaxScale is a Swiss Army knife. It's a great database proxy. It's well suited for MariaDB server deployments as well as MySQL deployments. And definitely there are lots of people that use it. You can write lots of plugins for MaxScale as well. Proxy SQL is the proxy for DBAs by DBAs. It's developed in an open source fashion, and it also supports Galera cluster host groups inside of the proxy itself. So it's kind of handy. Um, and of course, HAProxy, while it doesn't understand the SQL protocol, it's definitely commonly used as a load balancer in front of MySQL. And some servers also do support the proxy protocol, so that you can at least identify the IP address behind it as well. Now, for all intents and purposes, I guess the most interesting proxies are router, MaxScale, as well as Proxy SQL. And proxies can help with load balancing, can help with routing data. It can also help with saying, I'd like a certain amount of nodes to only be for writes and the rest are for reads, and so forth. And the proxies are definitely a part of your high availability infrastructure, so to speak. But now I'd like to get down to Galera Cluster itself. Galera Cluster is kind of fascinating. Not because you're at a Codership webinar, but because it's widely distributed. So MariaDB server, for example, in March 2017, so that's over 2 years now, said that they have over 12 million downloads. And MariaDB server has come with Galera Cluster for a very long time, and MariaDB server is in many Linux distributions as well. Percona XDB cluster, which is another distribution of Galera cluster, has over 1.3 million downloads. No dates, but this is live on the Percona website. Of course, we have more from galeracluster.com. We also do offer Yum repositories as well as app repositories, and we cannot count the distributions, distribution downloads. So we're included in many mainstream Linux and BSD distributions, from Ubuntu, Debian, Fedora, the upcoming Red 8, OpenSUSE, FreeBSD, and so on. So Galera is widely available. In fact, cloud platforms like OpenStack, for example, actually recommend Galera cluster when you want to achieve high availability as the backend. So again, reiterating the fact that there are thousands of users in various industries that have trusted Galera cluster for over a decade. I think that's generally quite impressive. And it's sort of just getting better now as well, with the upcoming Galera 4. It also won a MySQL Community Award, Application of the Year 2014. So it also shows that the community appreciate it, because it's been around for a while and it's running production workloads. Okay, so what can Galera do for you? Galera cluster is basically multi-master application, and your application looks at all of this as one large database with multiple entry points. You can read and write to any node. Naturally speaking, you can have automatic node provisioning. So you only need to bootstrap the first node, and every other node joins afterwards. And of course, you can add and delete nodes on the fly. Each node obviously has an identical copy of the data, and replication is basically virtually synchronous. It's well worth noting that transactions are processed locally until commit time and then replicated across nodes throughout the cluster. When we say it's virtually synchronous, it's worth noting that each transaction is, of course, generally immediately replicated on all nodes at commit time. So you don't have the problem of stale secondaries or lagging secondaries, as is common. Lots of people always say, "Oh, we're having slave lag or secondary lag," and this is not something you'll face with Galera cluster. Multi-master, true multi-master also means that you can read from and write to any node. You don't need a proxy in front of it saying, I only want to write to two of my 5 nodes and I want to read from the rest. You can read and write to any node because Galera also has automatic transaction conflict detection. And of course, when it comes to replication, the copy of the entire data set is available on all nodes. Um, One thing that's probably worth noting is that Galera is InnoDB only. So it works with the InnoDB storage engine, and that's generally maybe not a problem if you come from the MySQL world. But I guess we're starting to see MariaDB ships a myriad of engines, and maybe one of the more popular ones might be Myrox. And again, that's something about Percona ships as well. And Myrox is definitely not something that you can use with Galera cluster or not yet anyway. So that might be something that you can provide feedback to your vendor of choice, including us. Uh, Data consistency protections. So we really do avoid the ability for you to read stale data, and we don't want you to have unsafe data modifications. And Galera is supports wide area networks very well. Of course, we want to make sure you have low latency as well. So you can have nodes on different continents. We focus on end-to-end encryption so that you're not replicating in plain text. And of course, optimize your communications with the least latency possible. And Galera really is all about multi-master replication. It's high availability with no data loss. It's consistent data across all nodes. There's no single point of failure. So as long as you have three minimum nodes, all is well. And why do we pick 3 or an odd number? And that's largely due to the fact that there's quorum-based failure handling. So if you took 2 nodes and one happened to die, then 50% does not make a majority quorum. But if you take 3 nodes and one happens to die, you still have a 66.7% 2/3 majority, and because it's used the quorum-based failure handling, your cluster is still active and healthy. Naturally, it also uses optimistic concurrency control. So as said earlier, it will apply the transaction when it's time to say an OK. It'll apply to all nodes before it gives the client an OK. And all nodes really are equal in terms of having data, um, the same data, and you're up and available 24/7 with no lagging secondaries. And this is a core feature of the product. It's by design. The automatic transaction conflict detection and management um, is not an afterthought. It is something that is core to what Galera Cluster is all about, and this is why it works well again on WANs and clouds. It also can handle parallel replication, so it applies in parallel with the dictated commit order, and you can of course have many secondary applied threads started, and secondary control is row level based. So parallel replication makes things extremely fast, and you don't need any automatic failover frameworks to exist. You don't need to say I want only one node to have write and the others to read. Configuration is extremely simple. Basically, you open up your my.cnf and you add in a bunch of configuration parameters. It's also easier to handle scheduled downtime. So maybe you want to do an offline schema change. I mean, nowadays you can also do lots of online schema changes and so forth. But Galera really is truly about multi-master replication. Galera is also definitely optimized for use in the cloud. So if you have multiple data centers, for one, the network protocol is optimized, so packets are only exchanged over the wide area network at transaction commit time. I think that's generally quite important, so that you always ensure that things are as fast as they can be to the local data center. So you can have data centers, say in Singapore, another one in Mumbai, and another one in London, and all those three data centers can take active traffic. The other thing that's probably interesting is that it's also topology aware replication. So every transaction is sent to the data center only once. So in a typical WAN-based setup, you would have a minimum of 9 nodes. So three in Singapore, three in Mumbai, and three in London. And when it's time to write the transaction, say from the Singaporean node to the rest, it only has to write it 5 times, once to Mumbai and once to London, and then that gets written from so-called master node to the other nodes as well. Galera also supports the ability to detect and automatically evict unreliable nodes. So if you're having network flaps or regular node failures for whatever reason, maybe for some reason it's bad memory and the kernel keeps on panicking, it will not rejoin the cluster. If it keeps on being kicked out, then you need to have some manual intervention, fix the problem basically. And this is actually also good because you don't want to always have this problem of nodes joining and then getting kicked out all the time. Galera also has a split brain recovery as well as management, which is extremely useful. So you don't have two sets of conflicting data at any given time, and the traffic is encrypted. Now, later releases of MySQL. So a lot of you are basically saying you use MariaDB or MySQL 5.7 or earlier. Now, 5.7 does have a reasonable amount of SSL, but it's something that you probably also need to turn on better. Or you need to set up via SL MySQL SL RSA setup. Uh, but if you use asynchronous replication, by default, it's not going to be encrypted, so to speak, and that's something that is important because you're working in a cloud environment. You want to make sure that everything you send is not going to be captured. And later releases of MySQL definitely force this down your throat a lot more. But with Galera, it's definitely something that we've thought about for a long time, and it's also supported. Well, now to talk about InnoDB cluster and group replication. The underlying protocol for group replication is something called is Manicus, and however, the paper itself is similar to Galera Cluster, which was written in 2000 uh, as well. It's definitely much newer compared to Galera. Uh, so there are features, for example, like failover consistency, like eventual or read your writes, which only recently appeared in 8.0.14. And for context, 8.0.15 GA is out now, but 8.0 has been GA for over a year now. It was released on 19 April 2018, so just about a year at 8.0.11, and you're still getting features that are inserted into this. So I don't think it's maybe as mature, and they actually have a very good document on group replication limitations in the documentation, which is something I highly recommend you to go and read. Also, you can use the new MySQL shell for administration. It's something new to learn, but also it's quite an interesting way to administer things. Naturally, also again from the documentation, they actually do tell you that single primary mode with automatic primary election or multi-primary mode, multi-master, is where all servers can accept updates issued concurrently, but it's sold only as an advanced use case. So the general idea is for you to still have single primary mode with automatic primary election, as opposed to having multi-master by default, which is kind of interesting. And of course, there are also limitations around very large transactions that should be executed. And some of this is apparently mitigated in something that I've not been able to test, but it's because it's again in the documentation. it's in an unreleased 8.0.16 where large messages are automatically fragmented, basically broken up. But also it comes with TLS version 1.3 support in 8.0.16, but it's not quite there yet for group replication. So there are a bunch of things that I guess probably need to be checked on. It's also got a maximum of 9 servers in a group, but it does have one thing probably that the Galera cluster will unlikely have, is that it has the ability to work on Microsoft Windows, and Galera only works on Unix-based environments. So I guess InnoDB cluster and group replication will be more utilized going forward, maybe much later. But I think today Galera cluster is still a lot more fully baked, so to speak. So where can you get Galera cluster? Naturally, Codership is the upstream, galeracluster.com, the developers and experts of Galera cluster. You can also get it built into MariaDB server. We, Codership, work very actively with MariaDB Corporation, from working on roadmaps, testing systems together, as well as working with customers together. In fact, MariaDB Server 10.4 is the first release candidate. Now they've just published their second release candidate to include Galera Cluster 4. So that tells you that we are really working closely with MariaDB Corporation, and they are our trusted partner. So yeah, you've got definitely got upstream. You've got MariaDB, and then you can also get it as a separate download as Percona XDB cluster from Percona as well, PXC, and PXC is for all intents and purposes, based on Galera cluster as well. There are, of course, branch variants. Upstream, Codership's Galera cluster today has, variants for MySQL 5.5, 5.6, as well as 5.7. And releases tend to be within a month of release of what Oracle releases. And, we will actively work on the next release as well. When it comes to distributions, MariaDB Galera cluster has the Galera 3 library, with 5.5, 10.0, 10.1, 10.2, and 10.3. But with 10.4, they've got the Galera 4 library, and when MariaDB goes generally available later this year, in fact, in a couple of months, it will be shipping Galera 4 by default. As I said earlier, Codership and MariaDB work hand in hand to make sure that you get the best Galera 4 experience with MariaDB Galera cluster. The Percona XDB cluster currently comes with 5.5, 5.6, and 5.7 with the Galera 3 library as well. And I guess we'll talk a little bit about the future in a little while as well. So there are some interesting feature highlights from Galera 3.x and 4 that you may have missed. For one, there is the idea of intelligent donor selection, which basically prefers a donor that can do an incremental state transfer because it's much quicker. It doesn't block the donor node long and so forth. And of course, the other method is a state snapshot transfer, which is not preferred. So intelligent donor selection is something that you get with a modern release of Galera. Cluster crash recovery after, say, a power failure is available even in the 3.x branches. With PC recovery on, so all your nodes basically maintain cluster information persistently. So you don't need a bootstrap when it's time to restart. And this is maybe potentially a problem when you have power failure, all your nodes are gone, and so forth. One thing that's definitely interesting is streaming replication, which basically replicates transactions of any size, because transactions are replicated in smaller increments. So large transactions actually do work with Galera 4. So this is like a huge bonus. The consistency voting protocol, in the event of inconsistencies, if ever you manage to find inconsistencies detected, nodes can vote when such is detected, and this is also a new feature. And DDL optimizations previously could lock the entire cluster, but now the lock will only apply to the affected table as opposed to the entire cluster, which is again a huge boon. What is coming next? So Galera 4 is already inside of MariaDB 10 for release candidate, and now they've published two release candidates. So one could presume that a generally available release is not far off. Codership is definitely working on a MySQL 8 release, which will come in the future as well. And Percona is definitely working on Percona XDB Cluster 8.0, but of course it is unclear which Galera library it will come with. Currently, based on looking at what's available, it looks like it will be the Galera 3 library, but I'm sure at some stage it may also include a Galera 4 library. But again, we do not know what the plans are here. Largely, we can only tell you the plans of Codership and MariaDB Corporation. Cloud. The cloud is like extremely popular. Everyone loves to use the cloud nowadays because it also helps get rid of having a DBA, for example, until maybe it gets much larger. Uh, and I think by far the most popular is AWS RDS for MySQL and MariaDB Server. These, of course, do not use Galera Cluster. They are regular MySQL rep, and if you take the high availability option, the multi-AZ option, you don't get a second readable node because it makes use of DRBD for failover. So we already discussed the deficiencies of using DRBD for failover, and the fact that Amazon, and it's also the fact that Amazon charges you only about 50% extra for multi-AZ. Definitely, it used to be a suspicion, but has been confirmed by a video on YouTube because an Amazonian gave a talk about it. They do use the RBD, and it's a function of the fact that they launched the MySQL service back when DRBD was the best solution, and there was no, say, semi-synchronous and so forth available. Amazon Aurora is gaining a lot of popularity. People outgrow RDS, but you're also not getting 100% MySQL. You're getting basically a branch of either 5.6 or 5.7 with physical replication. So that's another different type of replication. So we've covered asynchronous, semi-synchronous, and basically fully synchronous or virtually synchronous replication. But there's also physical replication, which is something that you can do when you actually control the hardware that the database is being deployed on, and that's something cloud providers tend to be able to do. So Amazon's obviously got this with Aurora. The other one that talks a lot about this is Alibaba Cloud with PolarDB. Um, though I guess Alibaba Cloud may not be as popular as a cloud service as one would expect in many markets. But yeah, you're not getting full MySQL. You're getting a lot of the optimizer switches turned off, and it's different. And it grows up to 15 replicas before you also then have to think about what else to do. So we've also definitely seen people occasionally migrate off Aurora and then go back to say EC2 and then run maybe Galera or five seven releases. So from a general standpoint, this is not a bad solution. But also you'll find that it may be lagging updates as fast as you'd expect. These are general cloud things where HA is box more than you expect. And you don't get to control things as much as you think you can, because that's what the cloud is all about, right? It's not about you controlling it, it's about someone managing it for you. Now if you're wondering where you could get Galera cluster in the cloud, there are some platform as a service providers that definitely offer this as well. But generally speaking, it's still a much more of a roll your own solution in the cloud. And I guess if you're interested, we could definitely work on making sure that we give you more deployment scripts and so forth. So, in conclusion, I'd like to, definitely bring you back to the attention that Codership, we are the developers and experts of Galera Cluster. We've been doing this for a long time. The architect, the CTO, the CEO, the founder, they're all still very much around making this a better product. And as can be evidenced by Galera Cluster 4, um, and Galera Cluster, of course, has been used and deployed for over a decade. And of course, yes, there are many variants available, but that's again extremely useful. And I guess if you're looking for 5 nines uptime, you can't tolerate downtime, lost transactions, or data, Galera Cluster could be the right solution for you. So I'd highly recommend you to take a look-see. We're probably going to be running more webinars, more focused on not a general landscape solution, but on more on the product itself. So, like how you can do stuff with Galera Cluster, like how you can make, efficient backups, how you can do efficient deploys, and so forth. So we're gonna definitely do that. And of course, when you can get Galera Cluster in a non-release candidate, because we are responsible and we want to make sure you use generally available software, we'll also run webinars around that. And maybe if you have interest in Galera Cluster with proxies and so forth, we can also do that as well. So now we're definitely going to open up to questions. So you can actually post your questions, and we may not necessarily answer all of them, but we're definitely going to write a blog, and the blog will be then updated at galeracluster.com/blog. You can follow us for updates on Twitter at Galera Cluster, and yeah. So okay, I'm going to take a look see at the questions now. Why, hello, Claudio. What is the main difference between master-master replication and Galera cluster? So master-master replication, typically in the MySQL world anyway, has always been done via a framework, and the framework has generally been something called MMM. Now, MMM, in fact, if you go to their website, they will tell you to not use the product because it is, it's not maintained. Galera cluster is obviously maintained. Now, if you're thinking about master replication for, basically with a more modern MySQL, again, you still create the replication users, you still configure your database replication, but generally speaking, Galera doesn't focus only on having two masters, so to speak. Galera focuses on having a minimum of 3 nodes, and it is definitely multi-master. It's not just writing to 2 masters, and it's not having any other issues. But it's probably a good question that we should maybe also at the same time answer on our blog. But I'd say that master replication itself is is definitely complex to configure, and the likelihood of errors are much higher. You probably have a much higher chance of errors with something like MMM than you would with Galera. Galera is fairly easy to set up. It's unlikely to cause you any issues, and yeah, I think that's the advantage over master replication, is that we're not going to lose your data. So another question was, how do we prevent deadlocks caused by optimistic locking with multi-master writes? Yes, so that's an excellent question. Now, deadlocks do occur sometimes, and we have the option of allowing you to retry and auto commit. So this is something that if you have multi-master rights and a hot row, you can set the auto commit to retry at say maybe 5 times, and then you need to ensure your application also will wait for that to happen. So that is something that is useful. Now, now, is Galera cluster a drop-in migration from your regular MySQL? The answer also very much depends on how you are going to look at the schema and the architecture around it. So I think that's also something that's fairly important. Now, I did not put in these slides that Codership via galeracluster.com offers 24/7 support, and we also do consulting. You can do remote and on-site as well as training. And you know, one of those things that we also do is we'll also look at your schema and to tell you where you might want to change your schema if need be, if it was time to migrate to Galera cluster. So another question was, I do not get what PC recovery does. And yes, that is actually a feature not of Galera 4, but PC recovery. PC stands for primary component in Galera cluster, and basically all nodes store the primary component states to the disk, so you are able to recover it in case all the nodes go down for some reason. So if you are in, let's say you have 3 data centers and one data center, the one in Singapore, goes down because of power failure, or maybe it got flooded. Normally, when you restart that set of nodes, you would have to bootstrap the first node and then get the other nodes to join automatically. But since 3.6 of Galera, PC recovery has been on, and the primary component data is actually saved on each and every node in a file. It's like gvw state.dat, and node will create and update it when the cluster forms or changes the primary component. And if the node shuts down normally, it deletes the file. If it doesn't, it's always going to be there. And this is really there to help recovery, so to speak. Wow, we have quite a lot of questions. So we're not going to be able to answer all of them, but we're going to export the questions. And as I said, we'll definitely put that in a blog. Is Galera Cluster a good solution for shared web hosting environments, or do you recommend another solution? If you have a shared web hosting environment, as long as you're, creating a different database for each shared hosting user, go right ahead and offer a Galera cluster to your shared hosting environment folk. Maybe also interesting is that if you happen to use Galera cluster, say, again with MariaDB, it has other interesting features that help with shared hosting environments, like you can look at the memory used, for instance, and so forth. So yeah, that's something that you could definitely do. Shared hosting environments and Galera, not a problem. Why is Amazon RDS not using Galera Cluster as an HA solution? Well, Amazon RDS is actually maybe the second service that they offered after S3, and so it's been around for over 10 years, and they chose to architect with DRBD underneath it. They started offering with MySQL 5.1, if you may recollect. Actually, yeah, it was 5.1. So Galera really started appearing inside of the distributions around the MariaDB 5.5 release cycle, and of course PXE 5.5. So and MySQL 5.5. So I'd say that Amazon architected RDS before this was an option, and yeah, it's that's probably the reason why. But if you're an Amazon customer, you are more than welcome to, write to them in the forums and then tell them, that you'd like that. And, it turns out we have way more questions than we have time for. So to the rest of you, we are saving your questions from things like stored procedures, things like node consistency compromise, and locking, and master and blogging, and real world use cases with acceptable performance. Yes, we will definitely cover all of that in a blog follow up, as well as more individual blogs. So I guess with that, I'd like to say thank you for joining us for this webinar. Might actually be one of our first this year, and I hope you learned something new. And then we'll have a repeat of this webinar later for the American time zones, and let us know about what you'd like to hear going forward as well. So thank you for listening and attending, and we will send these slides to you as well with the blog, as well as the YouTube recording link once all that is done. So thank you.